Alright folks, so in this video we're going to take a look at a multi-tool from Mustool. It is this 8206 multi-tool that has the features of most multi-tools on the market, but has a couple extra ones, like the ability to generate a waveform, which is pretty cool. Now there's some problems or issues that came up during my testing, so let me know what you think in the comments below. Now let's go ahead and get started. Alright, so here is the multimeter. And I did want to say that I was contacted by Banggood, and they asked if I would do a video review of this meter. And I said yes, so they sent this to me free of charge in exchange for this video review. Let's go ahead and take a look at the box. Here are some specifications, and you can pause and take a look if that's something that you're interested in. On the top, I did want to mention it says multimeter and oscilloscope 2-in-1. Techniques Calibration Professional. I think calling this an oscilloscope is a little bit of a stretch. It really seems like it's a waveform interpreter, or I'm not going to say generator. But let's see what's inside. I have not opened this, so we're going to enjoy this moment together. This is a nice bag, I guess. The multimeter is in a zip bag. I'm a little surprised at the size of this meter. The dial is very stiff. And it does look like you could get it stuck between settings. The buttons seem to work okay. Let's see what else we have. Some probes. Get some of this junk out of the way. I'll roll in a picture that shows that these probes say Cat 3, 1000 volts at 10 amps. I'm not entirely sure that I would push that much juice through these. They appear to be made of plastic. They seem to fit in rather snugly. There's a little bit of a deformation here, but not a big deal. The bail seems functional. And in here you have a slot for batteries. I think I did that right. And it looks like I did. The display is actually pretty good. There is an off on either side of the meter, which is pretty handy. It looks like we have millivolts AC and DC volts. DC volts AC. I'm sorry, this millivolts is just DC. And then there is looks to be a frequency counter. Here you have your capacitance, diode, ohms, and continuity. Microfarad, milliamps, and up to 10 amps. Let's hook this up and do some testing. So I will include a link to this website below, but this is the Banggood website and the link specifically for the Mustool MT8206. And then you can see right now there's a promotion sale to May 31st, and this is selling for $48.99. In some cases, that seems a little expensive for a multi-tool. In some cases, that seems pretty reasonable for a multi-tool. This multi-tool does have some enhanced capabilities with the graphical capabilities. If that's something you need, this might be right in your price range. Maybe it's something you want to check out. We'll just take a quick look. When you come to this website, you'll be able to see other video reviews on this particular product. You'll be able to come down here and get a look at some of the different features and stats on the multi-tool. Here it is talking a little bit more about the features. I'm just going through this really quickly, and then here's what I wanted to go do, the product parameters, and you'll be able to see all this stuff in the event that you want to do some more investigations before making a decision to purchase this product. Also from this page, you can link to the user manual. The multimeter comes with a paper version of this manual, and the manual isn't bad. I've got to say that I've seen much worse manuals from plenty of different multimeter manufacturers. And this one's pretty good, and it walks through an introduction to the instrument or to the multimeter, some basic operation, and then some more advanced operation, including the waveform display. Okay, now we're going to test some of the features and functions of this meter. We're going to start off by going to millivolts. And this is a setting for millivolts DC. One of the things I wanted to mention is that this does have a very crisp, clear display. I'm quite impressed with that. So we just have our probe set up, and I'm going to test this battery. Now this is an Energizer Max battery that is pretty close to dead. And because I don't have a voltage reference that will display millivolts, we're going to go ahead and we're going to use this battery. So you can see that we're at about 316.5 millivolts. And that should be dropping. Now that we've disconnected, let's go ahead and move up to volts. Again, we're going to use a quick battery to test it first. So here's just a 9-volt battery. Let's see what we get. Oh, got it switched around. There you go, and you see 9.65 volts. Nothing unexpected there. Let's go ahead and pull in our voltage reference. Now we're running this off of a 12-volt lithium-ion battery. Let me go ahead and bring this into the picture here. It is live and hot, so I want to make sure that nothing happens. And we have our jumper set at 2.5 volts. So let's go ahead and test. And it shows 2499, which is within spec. Oh, there we go, up to 2.5. So that's perfect. Let me go ahead and carefully move this jumper. Now it should read 5 volts. And there we go, we're at 5 volts. Let's go ahead and move to 7.5 volts. And it's showing 7.48. Let's go up to 10. And it's showing 9.99. And I'm happy with that. Alright folks, so now we're going to take a look at measuring AC voltage. So I'm going to take my meter and I'm going to set it to the AC voltage setting. My probes are still connected. And then here we have a surge protector. This one happens to be from PowerAdd. When you do things like this, make sure that you're very careful, make sure that you're being safe, and then make sure that you fully read and understand the instruction manual that came with your multimeter. Let's go ahead and turn this surge protector on. And then we are going to go ahead and we are just going to measure. Now what you heard there is a beep telling me that I'm working with high voltage. And this is coming out at around 118 volts. What I can do is I can also change this to see the frequency of the voltage. Now we're going to play more with the graphical settings on this multimeter, but let's just take a quick look. And then here I can see the waveform of the current that is coming in, or the voltage coming in on my PowerAdd surge protector. Let's take a deeper look at this frequency measurement that you have on the Mustool. So we're going to go ahead and we're going to set our multimeter here. And let's go ahead and connect our probes. In this case, we're going to be using different probes, and I'll show you why. We're going to connect up to this Aneng AN808 because it does have a frequency generator. Our output on the Aneng, hopefully I'm saying that right, is set for 50 Hertz. And then you can see here we're reading 49.99. Now I can go ahead and I can increase this by pressing that button. And then we can keep increasing, and let's just see how the Mustool does. It made a jump to kilohertz. It doesn't look like it's going to measure in megahertz. And there we go. That is the extent of our output capability on the ending. But that's pretty cool, pretty neat feature. Okay, what we're going to do here is take a little bit of a deeper look at the graphical multimeter graphing display functions. And what I have here is a signal generator that will allow me to generate different waveforms at different frequencies. So let's go ahead and turn this on. And then once it's on, we want to switch to display mode for the graphics. There we are. And then we're going to go ahead and we're going to turn on this 1000 hertz or 1 kilohertz sine wave. And then once that comes on, I use these buttons to either speed up or slow down the time. So here you can see the sine wave. And one of the functions of this multimeter allows you to record these. So I can just hit this button, and that's saved that to memory slot H3. Now I get out of that by hitting the button again. Let's go back over here. Let's turn off this sine wave. And then this is just generating random noise. And so you can see that displayed there. Let me turn that off. Now this is an echocardiogram. And that is a little bit difficult to display there. I think I'm going to say that it just doesn't handle that well. Yeah, that just doesn't look right to me. Let's go ahead and try different. This would be reverse sawtooth. And then this would be forward sawtooth or just regular sawtooth. A triangle waveform. And square. Now, one of the things I'll say is that I'm not really sure as to how much quality is baked into this signal generator. So when we see some discrepancies in the actual wave pattern, I don't know if it's the multimeter or the signal generator. It may be a combination of both. But anyhow, it's pretty interesting. Let me turn this off real quick. And then what I can also do here is I can press and hold this button down. And then I can cycle through various waveforms that I have stored. So that's kind of convenient and kind of nice. I do appreciate the memory capabilities of this tool. Okay, now we're going to take a look at measuring the values of some electronic components. So let's go ahead and adjust our multimeter. This is for measuring continuity, resistance, diodes, and capacitance. And what it's set on right now is resistance. So let's go ahead and do that. We're going to start off here with a 220 ohm resistor. And it took a little time to get there, but there we are. I believe this resistor is 1000 ohms. There you go. And then I believe this is 2.4. And there you go. Okay, now it wants to measure diodes. And what we're going to be doing here is measuring the forward voltage of these diodes. Okay, admittedly, I'm having a little bit of trouble measuring the forward voltage of these diodes. And to me, this might be a little bit of a fail. Here is the N-ing, and as you can see, it has no problem getting a readings on these diodes. Let's try the Mustool one more time. And I'm not getting anything here, folks. So that looks like it's a little bit of a fail. So let's go ahead and switch to continuity. People like to hit these things fast to see that. But where this comes in handy is, let's say, for example, this is the test lead that I used when we were measuring the DC voltage. So let me just go ahead and clip this lead into that. I can come over here and check my connections, and I can see that I have continuity through that lead. The last thing that we want to measure here is capacitance. And so I happen to have a capacitor here. Whoops, it's getting away from me. Come here, guy. And that's a little bit over. It should be around 11 picofarads. But there we go. All right, folks. So admittedly, this is a test that always makes me a little bit nervous. We're measuring amps here. And the setup is we have a 12-volt Bio-NO battery, and then the power of that is split through a test lead that I made with the positive running into the milliamp setting on our multimeter, and then that's where we're set here on the rotary dial. Then we take the negative or the common out of the multimeter, and then we feed that into the positive on this ham radio. This is our idle current, so it is 178.3 milliamps. And then I just feed this back into the ground or the negative of the battery. Now what I'm going to do is I'm going to disconnect the battery, and then I'm going to move over to the 10 amp setting, and then we're going to move our dial, and then we're actually going to test various power settings here on the radio. All right, now we're set up there, and the first thing I'm going to do is our radio is on low power. So let's just go ahead and key it up and see what happens. Also, our radio is transmitting into a dummy load, so there's no reason to get upset without identifying a call sign. And then you can see while I'm keying it up, it jumps up to about 1.25 amps. Let's go ahead and go to our medium setting here. And then you can see we are at about 1.72 amps. Now we are at the high power setting. And we are at about 2.5 amps. It's important to note that this is a very, very low power UHF radio, but I like to use it in situations like this because I'm not drawing a lot of current, and it's just really being used today for demonstration purposes. Okay, we're going to take a quick look inside of this multimeter. Here are 4 screws, and I've already loosened these screws, and then you can just take the back case off. One thing I'll note that these screws just screw into plastic, so you do have a potential fatigue or failure point. I like to take a look at these connections for our probes. You can see that these are split rings. The metal looks thick enough. A lot of times in multimeters, this will look really thin and flimsy. Other times you'll see where this is almost a full circle. These are very tight when you plug your probes in and try to get them out. So I don't necessarily have an issue there. I'll roll in the picture so you can get a better look at it. The fuses for this, here's one right here, and then there's another one underneath. I don't know if you're going to be able to see that. These fuses are surface mount fuses, and that's a little bit of a disappointment. I'd like to be able to switch the fuses out in the event that a fuse blows. With this particular meter, you'd now have to take this board out, and then you'd have to desolder these surface mount devices and then put new ones on, if that's a capability that you have. Under here, you can see some protection circuit. Let me see if I can get a better light in here. And I'll roll in a pic, but you can see a small PTC and then a MOV. So it does have some input protection on there, which is nice. Then you have a capacitor over here. I'm not sure if that's part of the protection or not. This is the central processor for the unit, and I'll roll in a zoom on that so you'll be able to see what it is in case you want to look up the data sheet or something like that. Taking a look at it, most of the solder joints, they all look pretty good. Everything looks like it's put on here pretty straight. So I'm not really seeing any construction issues or anything there. This lip for when you put the case together is pretty good size. Now, a lot of times with these multimeters, they'll have a boot or a cover on them to protect them in the event that you drop them, or in the event that it explodes. It kind of holds all the pieces together, so they'll call it blast protection. All right, well, let's keep moving. So I just want to wrap up with some final thoughts on this multimeter. I like it, and it seems like a full-featured multimeter. A couple of different issues. One, we could not get the diode testing working. I even went back and reconsulted the user manual, and it's just not working. Now, I don't know if that's maybe my batteries. The power there is too low to do that test. I doubt that. I'm not sure what it is. I'll make sure to let Banggood know. The other thing is that I didn't like that the fuses were surface mount fuses. At $50, this might be a meter that you're interested in, especially if you wanted to use the graphics or the waveform generator function. You'll have to make that decision for yourself. At this point, I want to say thank you to Banggood for sending this meter to me for my consideration. Thanks to everybody for watching. I really appreciate it. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. Thank you.